This is question 2, A22 Physics 5, May 2008, and this is a question about electromagnetic induction or magnetic fields. State Faraday's law. I'm just going to write it down because we've written down properly before. I'll just write it down as the equation. E is proportional to or equal to minus delta phi over delta t. And when you write that down, you're going to say something about E being proportional to the rate of change of flux. If you write this down, you must explain the symbols. Next part is about stylus of a record player. Before the introductions of CDs and cassettes, one way of storing recorded music was to plant the data in a continuous narrow groove on the surface of a circular vinyl record. This method is now showing some return to popularity. The record is placed on a turntable which is rotated at a constant angular velocity. A stylus or needle is then placed in the groove, and variations at the sides of the groove cause the needle and attached coil to oscillate in a horizontal direction in a magnetic field provided by a permanent magnet. As a result, an EMF is induced in the sides of the coil. Figure 2.1 shows a simplified plan view of this. So the idea is that as this moves, this is moving, it's cutting lines of flux, and therefore there's an EMF induced in the coil. So as that moves, this is also moving and rotating about this pivot point, and then therefore this part here, the coil, is cutting through lines of flux and an EMF is induced across it. Figure 2.2 shows the variation of the angular position theta of the coil with time t as the stylus tracks through a section of the groove. Explain why the movement of the stylus creates an EMF. So you're going to explain that the coil moves as the needle moves. That causes a change in flux linkage. And therefore an EMF is induced. So the coil moves as the needle moves. This causes a change in the flux linkage and an EMF is induced. The maximum EMF in the coil is induced at times marked A, i.e. 0, 1 and 2 milliseconds. Making reference to the graph, explain briefly why the induced EMF is greatest at these times. Now, one of the things you could say is that the gradient is greatest. So the gradient is greatest here. But what I would say there is the gradient that when the stylus is perpendicular to the field. And if you just look at that in the diagram again, the stylus, when it's down in this position, then theta is equal to 0. Okay, that's when you're going to get a maximum EMF induced. Theta is equal to 0. Therefore, EMF induced is maximum because rate of change of flux is maximum. And that will get you all your marks there. So this is one suggestion, but that's a second suggestion there. Next question. The magnitude of the gradient of the curve at the time marked A is 600 degrees per second. This is the magnitude of the angular velocity of the coil at times marked A. Show that the angular velocity of 600 degrees per second is equal to an angular velocity of 10.5 radians per second. So 360 degrees, you know, is 2 pi radians. Therefore, 600 degrees equals 2 pi over 360 multiplied by 600. And that gives you 10.47, or to three significant figures, 10.5 radians per second. It can be shown that the magnitude of the induced EMF is given by this equation. And this equation again is one that might be given to you. It's one that you used to have to know. Omega is equal to 2 pi f. B is the magnetic flux density, A is the area, and N is the number of turns. And so if you just write down that equation and put in all the numbers that you have there, you know that B is equal to 14 by 10 to the minus 3. A is the area, which is, you have to convert into meters, which is 20 by 10 to the metre squared by 10 to the minus millimetre squared to metre squared is by 10 to the minus 6. N is the number of turns, which is 8. And omega is 2 pi f, and you have to work that out from your graph. Do you? No, you don't have to work it out because you've already worked it out above. Sorry about that. So you've already worked it out to be 10.5 above. And so all you have to do is that calculation. It comes out as 2.35 by 10 to the minus 5. Or in microvolts, it's 23.5 microvolts.